You know, when you look at a world map, it really makes you wonder, doesn't it? How did history unfold so differently across the continents?
It's a fundamental question.
Yeah, I mean, by 1500 AB, you've got some societies with steel, with literacy,
Hmm.
and others still primarily using stone tools.
Hmm.
Why that massive divergence?
What explains those stark inequalities that emerged?
Exactly. And that's really the core of what we're digging into in this deep dive.
And it's crucial to state right off the bat, as the original question posed to Jared Diamond implies, this has nothing to do with inherent racial differences.
Absolutely not. That's a key takeaway from the start. So we're tackling this by going straight to the source. Jared Diamond's big book, Guns, Germs, and Steel.
It's quite the undertaking, a short history of everybody for the last 13,000 years,
Wow.
essentially.
And he pulls from everywhere, archaeology, epidemiology, linguistics. It's incredibly broad.
Mhm.
Our goal here is basically to unpack the core arguments for you, get those key insights without getting totally bogged down in all the detail.
And Diamond's central argument, really, is that it boils down to food production, how its development varied across continents. That's the ultimate cause, leading to the more immediate factors.
The guns, germs, and steel.
Precisely, those proximate causes. Though, of course, technology, writing, political structures, they all play a part, but he connects them back to food.
Okay, so let's set the scene. Where do we start? Diamond takes us back to around 11,000 BC, right?
Yeah.
End of the last ice age.
That's the starting point. And what's striking is, back then, things were, well, relatively similar everywhere.
Like a level playing field.
Pretty much. Across all the inhabited continents, you had hunter-gatherers using stone tools.
Now, before that, there was the Great Leap Forward, wasn't there? Around 50,000 years ago in Africa.
Yes, a significant step up in human capabilities. We start seeing standardized tools, not just chipped rocks, but consistent designs and art, ornamentation signs of more complex symbolic thought.
Okay. And this is also when humans are really spreading out.
Right. We see the settlement of Australia and New Guinea maybe 40,000 years ago. That's huge, potentially the first use of boats, watercraft.
Wow. And also linked to the first big wave of large animal extinctions caused by humans, wasn't it?
It seems likely, yeah. A pattern we see later elsewhere, too.
And then the Americas, settled later via the Bering Land Bridge.
Probably around or after 12,000 BC. There's still debate about exact timings, maybe some earlier sites, but the main wave seems to fit that picture.
So the point is, for a long time, humans everywhere were living in broadly similar ways. It's really in the last 13,000 years that these dramatic differences pop up.
And you can even see this divergence happen on a smaller scale more recently. Diamond uses the example of Polynesia, the Moriori and the Maori.
Oh, right. Same ancestors relatively recently arrived.
Exactly. Common Polynesian roots, maybe only separated for less than 1,000 years. But the Moriori settled the colder, more isolated Chatham Islands.
Less potential for farming there.
Right. They reverted, essentially, to a simpler hunter-gatherer lifestyle. Smaller population, less complex technology.
Whereas the Maori on New Zealand's North Island.
They developed intensive agriculture. Much larger populations, complex societies, warfare, elaborate art.
So it's a kind of mini experiment showing how environment and subsistence strategy can drive societies apart really quickly.
Powerful illustration, yeah. Environment matters hugely.
Okay, so that brings us nicely to the pivotal development.
Mm.
Food production,
Oh, yeah.
agriculture, and herding. This is where Diamond says the big split really starts after 11,000 BC.
Mm-hmm. It's the major point of divergence. Because it didn't happen everywhere simultaneously, or even at all in some places initially. And how it happened varied.
So where did it start independently?
Diamond identifies just a handful of places. Southwest Asia, the Fertile Crescent, is probably the most famous and seemingly the earliest.
Okay.
Then you have China, Mesoamerica, think Mexico and Central America, the Andes region in South America, maybe the adjacent Amazon basin, and also the eastern United States. Those seem to be the core independent centers.
And everywhere else?
Yeah.
Did they just borrow the idea?
Essentially, yes. Or rather, they adopted the actual crops and animals that were domesticated elsewhere. These are the founder packages, you could call them.
Like Europe getting wheat and barley and sheep and goats.
From the Fertile Crescent, exactly. That package spread westwards.
So what was the big deal about farming? Why was it such a game changer compared to hunting and gathering?
Well, several massive advantages. First, just sheer numbers. Agriculture can support way more people per square mile. Much higher population density.
Right. More food, more people.
And critically, stored food. Surplus. This is fundamental. If you have a surplus, not everyone needs to be out finding food every single day.
Ah, so that leads to specialization.
Precisely. You can have specialists, craftspeople, priests, soldiers, chiefs, eventually bureaucrats, people who don't farm but are supported by the food others produce.
And it also means settling down, right? You can't be nomadic if you're tending fields.
Exactly. Sedentary life, which allows you to accumulate stuff, heavier tools, pottery, permanent houses, eventually towns and cities. Technology develops faster when you stay put and have specialists.
It's interesting how domestication happened, though. It wasn't like someone just decided, I'm going to breed a better wheat plant, was it?
Not really, especially at first. A lot of it was probably unconscious selection.
How so?
Well, imagine gathering wild wheat. You instinctively pick the plants with the biggest seeds, or the ones whose seeds don't shatter and fall off easily. Then, when you plant some of those seeds next season,
You're unintentionally favoring those traits.
yeah,
Generation after generation.
right. Or think about peas. Wild peas have pods that burst open to scatter the seeds, but a mutation for pods that don't burst. That's useless in the wild. The seeds just rot.
But for a human collector,
It's perfect. You can harvest the whole pod easily, so humans naturally select for that mutation.
and some plants were just easier starting points than others. The fertile crescent crops seemed like superstars. Wheat, barley, peas, lentils.
They had a lot going for them. Many were annuals, grew quickly, they had large seeds, giving a good return. Many were self-pollinating, which makes breeding true easier. And crucially, the wild ancestors were abundant in that region.
Compared to, say, trying to domesticate oak trees for acorns.
Much harder. Takes years to mature, breeding is complex. Or plants where the edible part isn't obvious. It's quite striking, really. Diamond points out that the vast majority of our staple crops today, the big dozen or so that feed the world,
Like wheat, rice, corn.
yeah, corn, potatoes, barley, sorghum, soybeans, almost all of them were domesticated thousands of years ago in those few origin centers.
We haven't really added major new food plants recently.
Very few. It suggests the early farmers pretty much explored the most promising options available back then.
So the Fertile Crescent had the right plants and animals.
It really did hit the jackpot. Not just the founder crops, but also the most valuable domestic animals early on. Sheep, goats, cattle, pigs, all four were native there as wild species.
Wow. And the climate helped too.
Yes, the Mediterranean climate, those long, hot, dry summers, were ideal for storing dried grains. That's crucial for building up that surplus we talked about.
And Diamond suggests maybe the pressure was higher there. Fewer fish? Maybe wild game getting scarce?
That's part of his argument, yes, that the hunter-gatherer lifestyle might have become less productive earlier there compared to, say, coastal areas teeming with fish, pushing people towards experimenting with cultivation more intensively.
Compare that to somewhere like New Guinea.
Yeah.
They developed agriculture independently too, right? But it was different.
Very different. They domesticated things like taro, yams, bananas, sugarcane. Useful crops, for sure. But crucially, no cereal grains like wheat or rice, which are storable, high in protein. No domesticable large animals for meat, milk, or pulling plows.
So their food production system just couldn't support the same population densities or generate the same kind of surplus.
Exactly, a major limitation right there, stemming from the local wild species available.
Okay, so you have these centers of origin. How easily did farming spread out from them? Did geography play a role there too?
A massive role. This is another key part of Diamond's thesis. Thing about Eurasia, it's basically a huge landmass-oriented east-west,
Right. Stretching from Europe to China.
which means that crops and animals domesticated in one part, say the Fertile Crescent, could spread relatively easily east and west along similar latitudes.
Because the climate, the day length, seasons are broadly similar.
Exactly. Wheat and barley developed in the Fertile Crescent spread relatively quickly to Europe, North Africa, India. The animals went with them. Things could adapt more easily.
But what about spreading north or south?
Much harder. Think about the Americas. They're oriented north-south, or Africa.
Different climate zones.
Totally different climate zones.
Yeah.
Corn, domesticated in Mexico, took thousands of years to adapt sufficiently to be grown productively in the eastern U.S. or the Andes. The spread was much, much slower. Latitude is a huge barrier to diffusion for agricultural packages.
And physical barriers too. Mountains,
Yeah.
deserts.
Absolutely. Deserts like the Sahara Limited spread south from the Fertile Crescent into sub-Saharan Africa, although some things did eventually cross. Mountains could isolate valleys. Tropical forests could be barriers.
So farming couldn't easily get from, say, the U.S. Southwest into California because of the deserts and mountains.
Right. California remained a hunter-gatherer territory for a long time, despite being relatively close to early farming centers. Same for Australia. Agriculture from New Guinea never crossed the Torres Strait.
Wow, okay. So uneven development of food production and then uneven spread. How does this connect directly to the guns, germs, and steel? Let's start with germs.
This is maybe one of the most powerful and grim parts of the argument. We mentioned agriculture supports larger, denser populations living sedentary lives.
Right. Villages, towns, eventually cities.
Those conditions are perfect breeding grounds for infectious diseases, what Diamond calls crowd diseases. Things like measles, tuberculosis, smallpox, influenza. They need a large population to sustain themselves, to always find new hosts.
Hunter-gatherer bands are too small and spread out for those diseases to persist.
Generally, yes. They might get hit by an outbreak, but it would burn itself out without enough susceptible people nearby. But in dense farming populations.
The diseases could become endemic, always present.
Exactly. And crucially, where did most of these nasty epidemic diseases come from?
You mentioned animals earlier.
Yes. The vast majority seem to be zoonotic. They jumped from domestic animals to humans.
Living in close proximity,
Yeah.
sharing barns, maybe houses, less sanitation.
Absolutely. Measles is closely related to rinderpest in cattle. Smallpox might have come from cowpox or a similar cattle virus. Influenza has links to pigs and ducks. Tuberculosis, also cattle.
So Eurasians, living with these dense populations and domesticated animals for millennia,
Got exposed to these diseases repeatedly. They suffered epidemics, sure, but over time they developed some genetic and acquired immunity within their populations.
but populations in the Americas or Australia or Southern Africa who didn't have those specific domestic animals in dense crowds.
They had virtually no exposure and therefore no immunity to that particular suite of Eurasian diseases.
So when Europeans arrived,
It was catastrophic. Smallpox, measles, influenza swept through the Americas, often far ahead of the actual colonists. Some estimates suggest up to 95% of the pre-Columbian Native American population was wiped out by these diseases.
95%, that's staggering.
It fundamentally altered the balance of power. It crippled empires like the Aztec and Inca, making conquest much easier. Similar devastating impacts happened later when these diseases hit populations in southern Africa, Australia, the Pacific Islands. Germs were arguably the most potent weapon.
Okay, that's a powerful link. What about technology? The guns part, broadly speaking.
Again, it links back to food surplus and specialization. If you have people freed from farming, they can dedicate time to tinkering, inventing, refining crafts.
Developing metallurgy, for example. Finding ores, figuring out smelting, working metal.
Exactly. And technology is cumulative. One invention builds on another. You don't jump straight to steel. You need fire control, then pottery, then figuring out copper, then bronze, eventually iron and steel. It takes time and specialized knowledge.
Which is more likely to develop in large, settled societies with surpluses.
Definitely. And Diamond also notes that inventions often happen before there's a clear need for them. Someone invents something, maybe as a curiosity, and only later does a practical application become obvious.
And diffusion matters here, too, right? Like the east-west axis?
Hugely. Technology spreads. If one society develops, say, metal weapons, its neighbors are under pressure to adopt them too, or risk being conquered. Eurasia, being large and relatively connected along that east-west axis, saw technology spread more widely and rapidly than in the more fragmented Americas or Africa.
Isolation could lead to losing technology.
Absolutely. He uses the example of Tasmania. Isolated after the sea levels rose, they actually seem to have lost technologies that their mainland ancestors had, like bone tools and fishing techniques. Isolation prevents both receiving innovations and the competitive pressure to maintain complexity.
Conversely, the Maori in New Zealand quickly adopted muskets once Europeans introduced them.
Right, because once one tribe got them, every other tribe had to get them to survive. It shows how quickly technology can spread when societies are interacting or competing.
Okay, so germs and technology linked to food production. What about political organization? The steel could also represent organized states and armies.
Yes. Larger populations supported by agriculture don't just allow for specialization, they almost require more complex political structures.
Why require?
Because managing conflicts, distributing resources, organizing large-scale projects like irrigation or defense, you can't do that effectively in a society of thousands or millions based just on kinship or informal consensus like you might in a small band.
So you see this progression from bands to tribes, then chiefdoms.
Right. Chiefdoms are larger, often with hereditary chiefs, maybe some social ranking. tribute collection, the beginnings of centralized authority and economic redistribution.
And then eventually, states.
States are larger still, more centralized, with formal laws, professional bureaucracies, often incorporating multiple ethnic groups. They can mobilize resources and manpower on a much larger scale for warfare, for building, for everything. Food production provides the demographic and economic base for this political evolution.
So more food equals bigger populations equals more complex societies.
That's the general trajectory, yes. Large societies need complex organization to function.
And where does writing fit into all this?
Writing also tends to emerge in these complex state-level societies, often driven by very practical needs.
Like keeping track of all that surplus food and tribute.
Exactly. The earliest known writing, Sumerian cuneiform, seems to have developed primarily for accounting, keeping records of grain, livestock, taxes, rations.
Not for poetry initially.
Not initially, no. It was bureaucracy. But once developed, it could be adapted for other purposes, recording laws, history, religious texts, literature, but its origins are often tied to the organizational needs of early states fueled by agricultural surplus.
And like technology, its spread was uneven.
Yes, limited by need and by contact. Some complex societies, like the Inca, managed large empires with sophisticated record-keeping, using knotted strings, quipus, but without a full writing system in the way we usually think of it. China developed its own system early on, and its relative geographic unity allowed that single system to spread widely within its sphere.
Okay, so let's pull it all together. Going back to that initial question, why the divergence by 1500?
Diamond's answer, in essence, is that the starting environmental conditions on each continent were different, particularly in terms of the available wild plants and animals suitable for domestication.
For raw materials for agriculture.
Exactly, and also the ease with which agriculture, once developed, could spread. Those continental axes, east-west versus north-south, and geographical barriers played a huge role.
So Eurasia got a head start because it had better raw materials and an easier access for diffusion.
That's the core argument. More productive food production earlier, supporting larger, denser populations for longer,
Yep.
which in turn led to
More potent germs through exposure to domestic animals.
faster technological development due to specialization and diffusion.
And more complex political organization, like states, capable of mobilizing resources for conquest.
And often the development of writing to help manage it all. Those are the proximate factors: guns, germs, steel, and related elements. But the ultimate cause lies in the environmental differences that shape the development of food production.
Contrasting with the Americas settled later, fewer ideal domesticates, a tougher access for spread.
Or Australia, with its incredibly challenging climate and soils for agriculture, limiting population density and complexity, despite humans being there for tens of thousands of years.
And it wasn't about the people. As you said, European colonists brought the whole package to Australia.
They imported the crops, the animals, the technology, the political models. It highlights that the potential was inherent in the environment and the available biological resources, not the people themselves.
Even within Eurasia, you see differences, right?
Yeah.
China versus Europe.
Yeah, that's an interesting comparison he makes. China's geography perhaps favored earlier unification. Large rivers connecting fertile plains. This led to rapid diffusion within China, but maybe also at times stagnation if a single political entity decided against certain innovations.
Whereas Europe's geography, mountains, peninsulas, islands kept it fragmented.
More fragmented, leading to constant competition between states. This could spur innovation as states competed militarily and economically, but could also hinder continent-wide progress sometimes if technologies didn't spread easily between rivals. Different geographic layouts, different long-term dynamics.
Does Diamond dismiss culture or individual choices entirely?
Not entirely. He acknowledges they can play a role, act as wildcards. Specific inventions, specific leaders, cultural preferences matter, but he argues these often operate within the constraints and opportunities set by the larger environmental and geographical context. They're not usually the ultimate drivers of the very broad patterns across continents over millennia.
And studying this kind of history is tricky methodologically. No lab experiments.
Right. It's a historical science. You rely on comparison, looking for patterns, using natural experiments like the Moriori and Maori comparison, or comparing different continents to try and tease out the significant factors.
So summarizing the big takeaway, it really comes down to the luck of the draw, environmentally speaking.
Largely, yes. The availability of domesticable species and the geography influencing diffusion set different continents on different trajectories regarding food production.
And that difference in food production was the engine driving disparities in germs, technology, and political power that shaped the world we saw by 1500,
Hmm.
and in many ways still see today.
It's a story about environmental possibilities and constraints, not about inherent differences in people, geographic luck, you could call it.
Understanding that deep history, it definitely gives a different perspective on global inequalities today, doesn't it?
It certainly provides a framework for thinking about why the world looks the way it does. We can't change the past, but understanding these long-term forces might help inform how we approach present challenges.
So, maybe a final thought to leave people with. Given how connected the world is now, global travel, communication, trade, are those old geographic advantages still as deterministic?
That's a great question. Have human innovation and global exchange kind of overwritten some of that geographic destiny?
Mm.
Or are those deep historical patterns, those legacies of early advantages, still subtly shaping our world today?
Something to chew on. How much does that 13,000-year history still echo?